Uh, um, Good evening, ladies and gentlemen. This evening, ka go tla ke le bontsha gore di-formula tsa motlakase tse re di dirisang for topic ya rona motlakase a bo re di tsaya ko kae. So, uh, ke mo re reng a bo re derive di-formula. Let me make something very clear. No one at your level is going to ask you to derive any formula. Ke just nna hela ke batla go kaetsa gore di-formula tse di tswa go kae just to make the topic more interesting. So ke batla ke le bontsha di-formula tsa rona tsa motlakase re go tle yang gore re nne le tsone. But like ke bua, no one in your exam is going to ask you to derive such formulas. Ke nna hela ka bonna ke go bontsha go jwa go teng. Only go UB ha o tla o dira BSc ke gone ba ka go botsang gore derive these formulas. Yeah. Um, um, First things first, ke let's ke buile mabane ke ra ke re here is our circuit. Um, Electrons flow around the circuit, being pushed by this thing we call voltage. So level of voltage again. We have here our negative terminal, and then we have our positive terminal. So can you imagine an electron sitting somewhere here? um, an electron sitting between the negative point and the positive point. Electron is being repelled. An electron is being repelled by voltage by the negative terminal. It is being repelled, being pushed away by the negative terminal, and at the same time, it is being attracted to the positive side. It is being attracted to the side. So an electron experiences two forces on its body. It is being pushed away, being repelled by the negative terminal, and at the same time, it is being attracted by the positive terminal. And that phenomenon of repulsion and attraction is what we call voltage, and that is what carries the responsibility of that gradient that pushes electrons around the circuit. So, in the same manner, the population of electrons that is going to be flowing around the circuit is dependent on this force. So, while the higher the voltage, the higher the population of electrons that are going to be flowing around the circuit, population of charge being electrons. And remember that these electrons create a wave called current. While a higher proportion or higher population of electrons flowing in the circuit will create a larger current. Yeah. Rally resistance again. Resistance inhibits flow of electrons. While the higher the resistance, the lower the population of electrons flowing in the circuit, and hence the lower the current. So I don't want to I'll tell you something. Ko physics, there is what you call proportionalities. Katale bona di proportionality gore ke bua ka dilo tse dintsi nyana. So if you take two or more proportionalities and then you combine them with the is an equation, is a formula. Yeah, if you combine two or more proportionalities, you form an equation. Let me show you. La ntlha, ke tla compare current. Ke bole ka bokimo to bone sentle. Ke tla compare current le voltage. So if you increase voltage in this circuit, if you increase voltage, what is going to happen to your current? If you increase the force with which you push your electrons around the circuit, the population of electrons flowing is going to increase. A larger force is going to push a larger population of electrons around the circuit, and as a result, current is also going to increase. So what if you increase the force at which you pushes these electrons, the charge, current being the shadow of those electrons is going to also increase. And by so doing, rare ha di oketsega tsotlhe, ha di-parameter tse pedi di oketsega tsotlhe, ha oketsa e nngwe e oketsega, if they both increase towards the same direction at the same time, rather current is directly proportional to voltage. Current is directly, this is what we call the proportionality. Current is directly proportional to voltage. Or re kgona go kwala re re voltage is same as voltage over 1. Voltage is the same as voltage over, dividing voltage by 1 still remains voltage. So current is directly proportional to voltage over 1. And then similarly, I will try to compare current le le resistance. I will compare current le resistance. Yeah. So remember what resistance is inhibition to flow of electrons. If you increase the resistance, or you are increasing the stoppage, you are inhibiting flow of electrons. If you increase resistance, what is going to happen to the population of electrons flowing around the circuit? Can you pause the video and then think for a second? How if you guessed, or if you increased the resistance, the population of electrons flowing in the circuit is going to go down. You got it correct. Yeah, you got it correct. If you increase resistance, the population of electrons, because when you can now, these are flow, the population of electrons flowing in the circuit is going to go down. And remember, current is dependent, the amount of current in a circuit is dependent on the population of electrons. However, if the population of electrons flowing in the circuit goes down, so will be current. Current then is going to go down. So if you increase resistance, current will go down. So the reverse is true. If current increases, we our resistance has gone down. How about the go physics? Current is inversely proportional to resistance. This is how we write it for physics. Current is inversely proportional to resistance. Current is directly proportional to 1 over R. But the proper way to say it, current is inversely proportional to resistance. Inverse or 1 over R. Yeah. Ba ba itseng ba tlile ba seng le dirile mmetsa wa topic ya di-power. O tla itse gore half, I got the 1 over 2. This is half. O tla itse gore half is equals to, in forms of power, half equals to 2 to the power negative 1. Half is equals to 2 to the power negative 1. Kana ha o supa gore wa ja. Ha o supa gore wa ja, o supa gore wa rutega, because kana ha o rutega, you have to change your vocabulary, you have to learn, you have to change the way you speak. So, however, half is equals to 2 to the power negative 1. Instead of saying 2 to the power negative 1, what inverse of 2? So just like inverse of 2. So what a half is equals to inverse of 2. So therefore, however, 1 over R, what inverse of resistance. Yeah. So it doesn't matter what I say, or a little bit. Let's say you talk about vocabulary, science, you talk vocabulary, math, because that's how you learn. Current is indirectly is inversely proportional to resistance. So if you combine these two proportionalities, you're going to form an equation. Level on the left side of this proportionalities, you have I here on the left side, you have I here on the left side. So here the bar I here on the left side. How do you combine the proportionality base? The bar equals I. Are you ready? In these two proportionalities, run the division line here 5. Then we put our division line here. We put our division line here. Remember, we have division line. We have V no 1. V times 1 give V. We have V no 1. What is our division line? And 1 le R. R what is our division line? 1 times R give R. So by so doing, we have derived our first formula guys. So Lona, your duty is not to do this, to derive this. Your duty as a BGCSE candidate is to memorize this formula. Formula ya ntlha motlakase ke current is equal to V over R. So formula ya rona ya ntlha motlakase ke gore current is equals to V over R. Current is equal to V over R. So at the same time, Baba Devlin Matzos Kenyan, we can change subject to formula demfa. We can change the subject to formula demfa about a rebellion fraction. There Thomas R both sides R cancel R IR. So I'll start covering V is equals to IR. V is equals to IR. So that's the first formula. I equals to V over R. Can I change the subject to formula rare V equals to IR, right? Yeah. How's now V zero? You got ready after we are happy. You have derived your first formula. Now let's continue. Our second formula of electricity. Or before I get general, like I wanted to say why. If you look at this formula, ra le current, mabane ke re ke re ha ke tsamaya ke ntse ke ruta le lebelleng goreng of these parameters, which one or these quantities, which one is measurable, which one are we able to measure ka instrument. Current re kgona go measure ka emitter. Are you happy? Yes, we are happy. Voltage re kgona go measure ka voltmeter. Are you not happy? Yes, we are happy. The only thing that you cannot measure is resistance. So we have to calculate. So if there's only one thing, say we calculate the rest, then more is a variable. The unknown variable, like what to begin algebra. If you have one formula and then one unknown or one variable, then you are happy with your formula. So this formula is a very good formula because it contains only one variable. We are happy about it. Then never latela formula rarna ya botu ya motlakase. Ra go later charge ke fa ra go later charge le current. So ra go later charge le current ke ra bokimanyana ra go go bona mo video. So if the charge that flows around the circuit increases, what is going to happen to current? Remember, current is the shadow of flowing charge. Or if the charge increases, even current is going to increase. If the charge that flows around the circuit, its shadow is going to increase. Moruta wa gago le ngwana le monyenyane le ha o swele motho motona. Ha ona motho motona moruta wa gago ona motona. So if charge flows, the current is also going to increase. Yeah. So charge is directly proportional. Charge is directly proportional to current. Yeah. Then we go on to compare charge. We compare charge with time. Yeah. So level la second entry. Charge, we are talking about electrons flowing around the circuit. If you're going to sit somewhere here, if you're going to sit somewhere here, mo circuit, somewhere here mo circuit, I will go to never what's the tally marks or bale electron fetang this particular point. Ha electron e feta wa tally ya wa 1. Kan electron ya feta demfa wa 2. Yung e feta wa 3, yung e feta wa 4, kan 5, electron e feta hala or tally the number of electrons passing a certain point in the circuit. Ko lo sala no ka go nako E1 kwana a be go te o bale dikolo tse di hetang mo E1 ha go le feta wa tiga 1 ke electron e hitile ya bo 2 e hitile ya bo 3 4. So potso ke gore ha nako e tsamaya, ha nako e ntse e oketsega, nako e ntse e tsamaya, dikolo tse di fetile mo A1 after nako e rileng di a go oketsega di a go fokotsega. It is only logical gore o akanya gore dikolo di a go tshwanetse di fetagele, di a go tshwanetse di fetagele. So the longer you stay mo tseleng o bala dikolo tse di fetang ko A1, the more dikolo tse di a go feta le dintsi. So if you are sitting on your circuit at a certain point, the population of electrons that passes that particular point is going to keep on increasing. Ko dikolo ha di fetile ha di le 10, ga gona jaaka 10 teng ka go botsega wela go tlase o ka mpa ya mateng for ha re se le e switches off. Otherwise ha so ba dile gore e hitile 10 can only increase, can never go down. So the population of electrons passing a certain point will keep on increasing as time goes. I think it makes sense. So as time goes, the population of electrons passing a certain point in a circuit will keep on increasing. How on the charge is directly proportional to time. Yeah, and like relay in the previous equation, these two proportionalities and then we combine them. On the left side of the equation, we have charge. We have charge here. To combine the two proportionalities, we change the proportionality sign to an equal sign. So on the right side of the equation, rale I le T, division line of B. So we have derived our second formula. Charge is equals to current times time. So every time you go over current or current get 10 amps e follow for 10 seconds or go to charge if it for if the ke 10 amps times 10 seconds in 100 coulombs. So every time you offer the amps le nako, your time has to always be in seconds. So you're going to multiply your current with time to get your charge in coulombs. So your second formula second formula again Q is equals to IT. Q is equals to IT. So when formula level. Can we measure time? Yes, we can measure time with this stopwatch. Can we measure current? Yes, we measure current with this ammeter. There's only one thing, charge, that we cannot measure. So we have only one formula, one variable. Are you happy with this formula? Yes, you are happy. If you have one variable, 2 is equals to 4b. We can find b. It is solvable. If there's only one variable, you'll be able to work out that unknown or that variable. So if you have one formula or an equation, it is solvable. You are happy with the formula. Actually, let's find our third formula. Our third formula of electricity. So our third formula, we are going to compare the amount of work done in the circuit, the amount of energy work done or energy in the circuit re compare le babereki mo seketeng. Babereki mo seketeng ke charge. So if o oketsa babereki ba bereka mo seketeng, tiro e ba go e dira ya bona kana batho ba le bantsi ba go dira tiro e ntsi. Tiro ya go dirwang ke batho ba le bantsi. Kwa motho a thiba tsa loane wa go baka tiro dira tiro nyenyana. Batho ba o dira tiro le 100 ba chaisa ke ba chaisa ba dira tiro le se kana ka 70 compared to ha motho a le one. So ha o ketsa palo ba babereki, tiro ya go dirwang ka letsatsi ya bona ntsi. Ha o ketsa palo ba babereki, tiro e ba go e dirang tiro ya bona ntsi. So if you increase the population of electrons in the circuit, the amount of work done in the circuit is going to increase. How work done is directly proportional to charge. So at the same time, let's work done, we compare the voltage. Work done, compare the voltage. But how voltage in 90, what is going to happen to the amount of work done? Megan, how is a voltage? How is a voltage? Voltage is going to push a lot of electrons, and the electrons in the so what how gets a voltage the range how gets a voltage the range the amount of work done in the circuit is going to increase. So similarly, right, work done is directly proportional to voltage. Combine the two proportionalities to make a formula. On the left side, work done. On the right side of the formula, Q V. Q V. So formula work done is equals to QV. Level line. Work done is equals to QV. What level I can offer charge more, I can offer charge more pozong. We can offer the voltage. We have 10 kilohms being driven around the circuit by 12 volts. What is the amount of work done in this circuit? We have 10 times 12 and 120 joules. 120 joules. Again, examiners don't like this formula. So it's a rare way to get questions that this formula. You know why? Well, can you measure work done? No, you can't measure work done. Can you measure charge? No, you can't measure charge. You can. There's no instrument that measures charge. There's no instrument that measures work done. So we have two variables. You have two variables. You cannot measure this one. You cannot measure this one. You can only measure voltage. So I don't feel a voltage even though here two variables. You won't be able to solve Q or W. So we don't like this formula for the fact that we have two variables in one equation. But it really math. If you have two variables, X and Y, for you to solve them, you need two equations. What are the simultaneous equations? So if you have one unknown or one variable, it is doable with one formula. But the moment you have two variables or two unknowns, you need two formulae, two equations. More simultaneous equation where 2 is equals to 4x plus y, y minus x equals to 3. It will solve simultaneously. Only two variables, we need two formulae. So this formula solve if you had if you had partner really two, we solve delay simultaneous. And of course, more to begin as to begin simultaneous equation, we have to further simplify this. We have to further simplify this until we have only one variable. And before we just established Q equals to IT. So how about Q what's near IT? Q equals to man, Q is equals to IT. We are trying to simplify this formula. Q equals to IT. About I view of math. Q equals to man IT. So rather work done. Work done is equals to ITV. It's more like a television station, BTV, ITV. So work done equals to ITV. Abangayelebala. A television station, work done equals to ITV. Memorize this formula. Level. Can you measure current? Yes, with an ammeter. Can you measure time? Yes, with a stopwatch. Can you measure voltage? Yes, with a voltmeter. So there's only one variable. Do you love this formula? Yes, you love it because there's only one formula. There's only one variable. So this is why in exam we measure a morphine, calculate the morphine. We love this formula more than this one because there is only one unknown, only one variable. So instead of memorizing this one, we love this formula. Yawarin, work done. Work done is equals to work done equals to ITV. So le memorizing formula re fa la ke dikgabane ya le hore a go le gontsho go tlhaba so re simolola. So we simplify this one to get this one. Mm. So instead of work done equals to QV, we simplified it or in the work done equals to ITV. Simple like that. Yeah. Therefore, we move on. We we move on. Um, we move on. So let's get with my how to discuss power. Gore it is not only important for the tiro, work done, this ability to do work. Yes, we have done the job, but it also matters for with the relay na tiro mo nakong e kana kang. What do you call power? Power is equals to the amount of work done per time. So one formula is very famous, it's very common. Power is equals to the amount of work done. Power is equals to the amount of work done over time. Power is equals to the amount of work done per time. Yeah, power equals to the amount of work done per time. Ke gore o dirile tiro e kana kang mo nakong e kana kang. O dirile tiro e feng mo nakong e kana kang, right? Self-explanatory. So from the easy because here also trying to use from to begin some motlakase. Le wena gore o tla bona dipotso mo go yone tle re ntse re dirisa re feta hele because ga se ya motlhala go tsa re compare but this one is the general formula ya physics here but ra etsa re dira topic ya re dira formula ya motlakase yaanong how o sena itse gore power is equals to work done over time mme kana ra itse gore ko motlakaseng work done ke mang ko motlakaseng work done is equals to ITV. Work done equals to ITV. Yeah. Work done is equals to ITV divided by T. So power equals to ITV divided by T. Power equals to ITV divided by T. While T you cancel a T. Power equals to IV. Power is equals to IV. You have formed another formula. Power is equals to IV. I get one school. I always found ways that I can memorize the formula. Like you got work done, it gets a television station, ITV. Formula power or saka ilebala. ne ke nna ke tlhola ke imagine akere kana for you to build knowledge you use what you already know to form a new to attach that knowledge to your brain cells. So ne ke nna ke imagine gore there is this guy o re balang from 5 lane o bitswa gote power ke la itake. So power e la itake ne ke tlhola ke imagine gore ke na le tsala e nngwe ya mosadi ke o bitswa gote Ivy. So ne ke nna ke imagine in my mind gore power o jola le Ivy. So power equals to IV. Ne ke sa nkile ba re tseletsa gore power o jola le IV. Power is equals to IV. I can have batho ba jwala gape ba lekana ngwate ke half o mongwe ke half o mongwe ke half whatever it means, but ne ke go dirisa gore go nthusa gore ke se ka lebala gore power is equals to IV. Power is equals to IV. So gore o pasa exam gore go di nne motlhofo kgone gore o di lebale, you have to find ways tsa gore o kry-e medile. Batho ba bangwe tla re hey motho le ga se gore o botlhale o le ke gore a grammar whatever it takes gore o kgone gore o pass, whatever it takes gore na le kitso, be proud of doing it. O se ka re tsa information diponyana tse dinnyane tsa go tshwana gore hey motho le ga se gore o botlhale wa grammar. Go grammar ke gone botlhale. Batho ba mo ke motho a bua le gore ke motho o se matla, right? Yeah, go grammar ke gone botlhale. Go botlhale ke gore thena kitso. So power equals to IV, power equals to IV. Be proud to say that. So we have level ra in formula ra rona gore power equals to IV, power equals to IV. Ebe tla re taolosana lebella ha le bella formula ra rona e go godimo le re rile I equals to V over R. Re rile I is equals to V over R. So ha go I ka re I ke V over R, ha go I ra go tsenya V over R, ha go I ra re power is equals to ha go I ke man V over R times V. I got a power equals to IV. Me V o ke ntse ke V over I over ke man ke I equals to V over R, tsentse V over R here. So re fetsa re V times V nama V times V in V squared divided by R. So what power equals to man? Power equals to V over R. So look at my more examiner was doing how Formulae done at the time, you can find power. How Formulae current and voltage, you can multiply them to find power. How when about current, about voltage and resistance, you want to find power. So I will power is equals to V squared over R. So one more thing, there are many ways of killing a cat. How about if you V, the R, you still can find the power of the circuit. How about if you the I, the V, you still can find the power of the circuit, right? Yeah. So I think when I have been able to have again. Not when I would again. So when I have a power is equals to IV, power equals to IV. Me had a regular. How do you V the subject of the formula? How V equals to IR. V is equals to IR. So how V has IR. Resala ka boreng I kiwa maha. And then how V V equals to IR. Retina IR. Refala re nna le bona gore I times I ke mang ke I squared times R. So what power equals to man? Power equals to I squared R. So what na go se dingwe ra go fa current le resistance di le two be re batla power. wa go square I bo terms aga r to get the power. Ha go ngere go fa v le I o ira ngwa iv to get the power. Ha go ngere go fa v le r re batla power wa go v squared uh v squared over r. Ke a go bolela tsotlhe di a go fa answer e tshwanang. So re na le formula ra rona number 7 ya gore power is equals to I squared r. So re bala topic ya rona ya motlakase gore o e pass. There are only 7 formulas. Tota bile di sikise because e tla ntse re itse. So these few formulas you have to memorize. How mo ke ntse ke go dira go di driver, you don't have to know how to derive them. You just have to memorize all these 6 or 7 formulas. Memorize it, then we are going to use only these formulas in our calculations. I will pass topic ya motlakase. Very simple. It is ka tlhogo lebela gompieno gore o ka di bua go duletsela ore current is equals to v over r, v equals to ir, q equals to it, work done equals to itv, power equals to work done over time, power equals to iv, power equals to v squared over r, power equals to I squared r, right? Ke batla gore di kreme di ntse helalo. Nna ha ke le ngwana sekolong nna kwa rona ha ke na le throwing chance ha le ga se di motlakase ko sekolong ke a memorize di ntsa ha ke ja lunch ka break ke ja lunch ke ba jwa pele ga be ke nna ke bula go ke ikgabola di formula tsele bosigo before ke robala ke tsa mo dikobong ke ikgabola di formula ke di rehearsa mo tlhogong ha ka re bosigo ke thantsha ke moroto wa ra bisigo ka before ke robala a be ke ka di kgabola be ke sa di kgabola sentle ke a tswa ke go bula buka ke go di krama gape bosigo ka thantsha ke moroto ke a di kgabola phakela first thing in the morning ha ke tswa ke a di kgabola gape gore if I learn something new that particular day ke tla ke se opela mo tlhogong ya ka ke tsamayang teng e nna le ke a rapela motshegare rotlhe ha bona go tire ba kriste ha gore le ba kriste you have to always be praying. What tirong mo khombing wa always be having that silent prayer in your mind. Le ha le ngwana sekolo no ira helalo o tlholo ntse o rehearsa tiro ya sekolo o tlholo rapela tiro ya sekolo motshegare rotlhe, right? That's how you learn. Repeat. So this is the second part of electricity topic. I think topic ya gompieno ne botoka echo ga e kalo. So in our next presentation ke tla ke leka etsa the difference between parallel and series circuit. Yeah. Then ke tla ke le bontsha hela ka tla ke tla part 3 ya motlakase, then ke tla part 4 be re part 5 be re tswalla, then be re ka dipotso. Thank you so much for your attention. I hope that helps. Good night.